Started. All right, so I want to. Project part 2 is still not posted. I'm on it. I'm working on it. So I do want to at least give you a heads up on what project part 2 is going to be. I can verbally describe it to you. I'm still working on the whole write-up to make sure everything is described and with the wording that I need, with the testing procedures that I want, and all that stuff. But here's what part 2 is going to be. Number 1, objective 1 is going to be auth. We don't know what auth is. I was going to say it shouldn't be any mystery of what this means to you, but I guess it is. We haven't covered auth yet, but it is homework 2. You'll be doing it in homework 2. We'll talk all about what auth is, authentication. And when you log in, so that's going to be register and login, and when a user is logged in, they'll be able to see their username somewhere on the page. That's going to be the requirement for to verify that objective 1 is done. When you log in, your username is displayed on the page. Number 2, users can make posts. Once they're logged in, they have some form where they can submit a title and a description for a post, and that post will appear somewhere on the page with their username. And then objective 3 is going to be adding a social media button of your choice. I'll probably just word this to be likes, and then you can change it to whatever you want. But adding a like button to posts, and whenever a user likes a post, it'll increment the number. It'll be, what you would expect this feature to be from any social media site, of all the verbiage to make sure we're 100% in agreement on what this means when I write up the whole write-up. But some social media button where people can like, and you can only like a post one time, and your app will remember which users like the post, and then just display the number of users to end users. So that's project part 2. This, of course, will be a team project. You'll work in your repo that you submit for your team formation, which, I guess I should do another team formation reminder. Either at the bottom of project part 1 or in the syllabus, there's a team formation form. And this, if you're in a team, if you have your team decided, you need to fill this form out before Monday. Right, just to double check. Project Part 1 deadline, Monday, September 25th at 9 a.m. That form has to be submitted, and then I'm going to form anyone who's not in a team into random groups. So anybody who doesn't pay attention when I'm saying this and didn't listen the first 3 times I said this and isn't listening now or isn't in the room, God forbid, I'm putting you on random teams. I just don't care. I've run out of tolerance for that over the semesters. I will put you in random teams. You will not be on a team together if you don't fill out the form. Fill out the team formation form if you intend to be a team, or you will not be a team. You will be placed on a random team. There's one group every semester after the deadline. I send out the email, say you're on a random team, and they say, we're totally a team. But if you don't let me know, you're not a team. You're just not a team. I don't care. I'm putting you on different teams. You have 4 full weeks to do this. Not tolerating it at all. All right. So that's that. That's project part 2, and probably your last. I don't feel like giving another one on Friday. Probably your last warning on that. So those of you who did fill out the team formation form, that's the last time you'll have to hear me say that. So let's get to the slides we had last time. We had a couple slides we just didn't quite get to. I want to talk about some JavaScript. And we got a lot of content in today's lecture, so I don't want to spend too much time on this. But in JavaScript, when you go to a website, you download JavaScript, you run that code on your machine, which is, in general, a very unsafe thing to do, to run somebody else's code on your machine. There are tons of security risks with this. Code has a lot of access to your machine, and they can just wreck everything, steal all your private data, install a keylogger. They can do whatever they want. So JavaScript has, at least when JavaScript ran in the browser, does have some restrictions because of this. The big one that you'll notice is you can't read or write files using JavaScript that's running in the browser. You just can't do it. This includes files that you wrote and hosted. And this is where it gets trippy. Every web developer at some point runs into this issue and wonders why can't I do that? So say you have a file on your server called awesomestuff.json, and you have some JavaScript that wants to read that file. So you send a request. So you have a request that gets that file, and then you say, okay, now open that file on my user's hard drive because I know my user had to download that file. You can't do that. You cannot do that. It's not allowed. If you want to read your own CSS file, your own HTML file, using JavaScript, you can't do it. So it doesn't even matter if you're clearly the owner and author of that file, you can't read it. It's not allowed. For very good reasons, for security reasons. You can't change that. You can't change those files. And you are contained within your tab for that page. You really don't have much access to anything else on the machine, including files. Files, not at all. But outside of your environment for your page, you really don't have any access. And for good reason. If this weren't the case, the internet would be an absolute madhouse. It'd be crazy. And there are always vulnerabilities. They get patched out pretty quick. Here's a very simple script. This is basically what the homework 1 JavaScript did. This get element by ID, I find this to be usually my most useful JavaScript thing. At least we're doing basic JavaScript stuff. Grab an element. That gives you that element, that HTML element. You can tell this is old code. I should update this. I still have var instead of const. And then you can modify that element. Here I'm going to modify the inner HTML and set the HTML equal to this content. Inner HTML is anything between the open tag and the closing tag. I'm going to replace all that with this string here. If you want to just append to it, you can do plus equals and leave everything that was there the same, and then just append to it. And lots of other things you can do. Any properties. This is, by the way, when I say you can't edit your own CSS file, this is how you would actually do that. You would grab the element and then modify the styling this way by getting the element, not by reading the CSS file itself. You're going to change the properties, the CSS properties after the page loads of that specific element, not the code defining that element. And then we put our script. We have to import our script in the code. We're going to put this at you have choices here. You can put it at the bottom of the body like this. That means that your script is going to download after the body loads. So since it's the last HTML element, we're going to hit this one last. And now I know my div exists by the time my code runs. And in this example, I'm using my JavaScript as an actual script where this script is going to run as soon as it's downloaded. So we have to be careful where we put this script tag, where we download the file, and what that code is actually doing. If your JavaScript is a library, it's just a collection of methods that are going to be called throughout the user using your web page, you can put your script up in the head. That's perfectly fine. But if it's meant to be a script like this one, and I put it in the head, this code is going to run before my div exists. So just being mindful of where your JavaScript is. The way I have it set up in the homework code, I have the script at the bottom and then an onload on the body to make sure that the body is fully loaded before running my JavaScript. So there are options here. Just make sure your code is ran and executed when you want it to be executed. And then it adds the content to the page. No surprises there. JavaScript is built to be event-based. This is an event-based architecture. And many of you probably took 116 when we still taught this in 116. This is where one place where that's going to apply heavily. JavaScript is event-based, and we can specify code that's going to execute on certain events. So on this div, I'm going to have it when the mouse enters, on mouse enter as an event. That means whenever the user, say this is my div, whenever the mouse enters that div, this code is going to be executed. And whenever the mouse leaves that div, this code is going to be executed. And I can put any valid JavaScript in these as reactions to these events. But it's usually good practice to call methods or functions at this point. I teach in Java. I'm used to calling them methods all the time. I'm going to call these functions. So when the mouse enters, I'm going to call the makeBlue function and pass this, which is a reference to the element that's referred to by this tag. So I'm going to pass that element, grab the element, change its style, change the color to blue, And on make green, pass the element, change the color to green. So now this front end is going to react to actions that my user takes. That's what we really want JavaScript for. Let's react to actions that the user takes. And we do that with events and reacting to events. Nothing more I want to say there. When we open the browser console, when you right-click and go to Inspect Element or open up DevTools, there's a tab for console. If you go to that console, that's where console.log logs to. That's why it's console.log in JavaScript, because it's logging to the browser console. So if you ever wonder where that comes from, that's where your console.logs go, the browser console. Console, log this. And I'll talk about browser extensions at some point, but not today, because I got a lot of slides for today's lecture. So let's just catch up from last time. To shorten document.getElement by ID, I don't think there's any shorthand for that. Certain IDEs might. I don't know. For some reason, that one doesn't bother me. The same system.out.println bothers me. So I never bothered looking into it, but there probably is. And for what it's worth, I like getting element by ID and then giving my elements ID. I usually want to get just one element. But for what it's worth, you can get elements by class name. You can get elements by type. Document.getElement by, I forgot. Is it just type? I don't remember. And then saying like div. You can get every single div on your page and iterate over that data structure to modify every single div if that's something you want to do. So you don't have to do it by ID, but this one, for my money, I just find that one most useful most of the time. But sometimes I want to go through every object with a certain CSS class. It's whatever. You have methods there for you. All right, post requests. I talked about these briefly, but not in any detail. So let's talk about it in a little bit more detail here. And to be honest, there's not a lot I have to say about post requests. But there is a bit more that you'll have to do when you go to coding. It's one of those topics where in lecture I'm like, yeah, that's it. This is a post request. But then when you go to code it, there's extra steps that you'll have to take implied by the structure. So post request, it's a request that contains a body. That's mostly it. More accurately, we're going to have our new lines. So we're going to have our headers, everything formatted the way we'd expect, /r/n/r/n, and then the body. No new line after the body. And this is the same exact format you've been using for your HTTP responses. Same exact format. I suppose except for the request line is going to be different than your status line. Other than that, it's the same format for the headers, for the actual body. You got that new line, all that good stuff. Same exact thing as you're sending, which means you're going to have content type and content length on the headers of your post request. So when you're receiving a post request, you're going to have content type and content length will be part of your headers. It's strongly recommended. I forced you to do this semester, so I probably should have removed that. You're going to see this /r/n/r/n, and then after this, you're going to read number of bytes equal to the content length. So this becomes a very important thing. Content length becomes very, very important. To be honest, less important for homework 2, very important for homework 3. This will come back in a major way. So content length of 5, you'll read this header, check its value, and then read that many bytes after this blank line. So I'm going to read exactly 5 bytes. This is why we don't need a blank line at the end of the body. This blank line here is telling us when we can stop reading headers. That's its purpose. It has a very specific purpose, and it does that purpose very well. You receive a request, you look for this blank line, and everything before that's headers. That's why even our GET requests, that's why even our, we haven't sent a response with no content yet. But if we send a response with no content, it's going to end with this blank line. It's very important for that to be there because parsers in the browser and parsers on your web server, they're going to look for this And when we find this, we know that's when the headers stop. Then we can parse the headers. In the headers, we're going to see content length. Content length tells us how many bytes to read after that blank line. So we don't need another blank line after the body because we don't have the same problem. But we need this one because we need to look for that to know how to parse this thing. So after the blank line, read content length number of bytes. That's the body. And then after you parse the body, read content length number of bytes, then it's whatever this path is supposed to do. It's, I hesitate to say this, but content type doesn't matter as much. In production, you should read that and make sure you have the right content type that you expect. But honestly, it's going to be the type that matches the type that you expect for that path. If you have a path that's expecting JSON, it's going to be JSON. We're not going to, maybe someday I'll do this, but we're not going to test your code with the incorrect content type and make sure that your path correctly rejects that. We're not going to do all that error testing on your, make sure your server handles that gracefully. We're not going to do all that. So if it's a path that expects JSON, you can assume content type's JSON. If it's a path that expects plain text, you can assume plain text. If it expects multi-part form requests, which we'll do in homework 3, you can assume it's a multi-part form request, and I'll be okay with that. But content length you will have to read. At the very least, if you try to skirt around this on homework 2, you will have to do it in homework 3. Guaranteed. You'll have to read content length. Just do it now. You won't have to worry about it later. Query strings. So query strings let us add more information in the URL of a request. Are we able to split on the blank line and then read the request if it exists? In general, no. For homework 2, you'd get away with it. I wouldn't get in that habit, though. So split in Python does take a second argument. If you give it a second argument, it'll say split at most this many times. I would get in the habit of that. So the problem with splitting, like straight up splitting on the new line, this blank line character, the first appearance of this sequence means this is the end of the headers. But you don't know anything else. You can't assume anything else than that. So this byte sequence, this sequence of 4 bytes, can appear in the body of your request. So if you're just straight up splitting on this sequence, you might have chopped the body in half. And then you're going to get all kinds of wacky results. And your images, when we get to homework 3, your images aren't going to load, and you're going to be wondering why not. And it's a pretty hard bug to find if you don't know what exactly to look for. So I would get in the habit of not straight up splitting, but if you split and say split at most one time, and then not chop your body in half, it's good to write that code now, and then you won't even have to think about it in homework 3. So finding the index of this and then splitting based on the index, or use Python's split, but split at most one time is the thing that you want there. So our query string, just a quick recall. We talked about this a while ago. It was a while. You can have a question mark in your URL, and then after the question mark, a series of key value pairs separated by ampersands, and each key and value are separated by an equal sign. So you can specify extra information in the URL itself. And we had fragments too, and I don't feel like talking about those more than what I already have earlier in the semester. But these query strings give us extra information in the URL itself. So we have these special characters. Question mark says, I'm starting a query string, and then the other ones, I just explained them. I don't want to say it again. But since this is in the URL, ASCII only. Since it's in the URL, no white space. So we do have some limitations with these query strings. If we do want those characters, we're going to percent encode them, or URL encode them, as it's sometimes called. We're going to percent encode. So if we want this character as part of our query string, we're going to percent and then the byte, percent byte, this being a 3-byte character, and this is how we would encode it in a URL. And if we want spaces, which we usually want spaces allowed, %20. If you ever see a URL with a bunch of %20s in it, those are spaces. Those are URL encoded spaces. It's common to use plus instead of %20. I don't know why so many sites do this, but they do. Plus is a character reserved for representing multiple values for a single key. And search engines will typically use the plus sign and other things. We'll use the plus sign in place of their spaces. So instead of saying, this is one string containing spaces, it'll say, these are multiple words that are all values of this one key for what it's worth. So plus sign, if you see that like in the examples here, the plus sign here was a space. Like I actually typed into my browser web space development, and then the query string that was created for that search, they replaced my space with a plus sign instead of a %20. So for what it's worth. There are quite a few reserved characters. A lot of these we already know what the meanings are, like ://. That's after the protocol that we're using, HTTP : Those are reserved for URLs. Ampersand we just talked about. Question mark we talked about. This starts a fragment. Plus sign we just talked about. And then a few others. I don't know what all of these are off the top of my head. But these are all reserved characters. You cannot use them in URLs. So you would % encode those. I'll say I should just add this to the document. We will use these in homework too. I will say you just don't have to worry about % encoding. I'll just throw that out there. You don't have to worry about % encoding. We just won't use reserved characters or non-ASCII characters or spaces during testing. So don't have to worry about this, but I do want to get this content out there so you know how these are handled. Notable non-reserved characters. You see these all the time in URLs. / _. You see these all the time in URLs because it's all we got. It's all we could really use. So many other special characters are reserved. Oh, and if you do want to handle % encoding in your homework, by all means, I'm not going to stop you. But I'm not going to make it a requirement. Just because it's an extra step that has little to do with what I want you to get out of the homework is the only reason. Your production code out there in the real world better handle those characters. Okay. HTML forms is the first additional HTML element that we'll talk about, and maybe the last, I think. Anyway. So we've hosted static content. That's fine. We have what I call poster sites at this point in time after homework 1 and everything we've seen in lecture. But how do we get dynamic pages? This is what we actually want. This class is called Web Applications, not Web Pages, not websites, not front-end development, none of those things. It's Web Applications, which means we want our users interacting with our server. We want actual interactions, typically between our users, between two users where web apps get interesting. Feel free to disagree, but that's where it gets interesting. That's where the internet gets exciting. So we want to make our pages dynamic and make web applications, turn our pages into web applications. So let's start doing that. The first thing I want to try to use is an HTML form. I mean, we will use it, but we'll see a whole progression throughout the whole semester of how to make our pages more and more engaging. So here's an HTML form. So we're going to use the form element. And I have tons of slides. I'm going to try and not get ahead of my slides. We're going to use the form element and then multiple inputs and get a form that's going to look like this if we use that code. When a user submits a form, they're going to click our submit button. That's going to send whatever they entered to our server in an HTTP request. It's an HTTP request, so what are we going to do? Respond with an HTTP response. That HTTP response is going to be the new page that's loaded when this form is submitted. HTML forms set up like this are going to refresh the page. This is going to send a request get a response, and whatever that response contains, that's what's rendered to the user. So ideally, that response would be either a redirect or HTML that's going to be the page that's supposed to load after the form is submitted. But it does navigate the user away from the page where that form was. Yes?
Would these just be two HTML, like two different files? Like when you refresh the page to get the new content, would that be sending
It's whatever you respond with. So you can just respond with the same HTML file. But it's whatever you respond with. That's what the user's going to see after they submit this form. Or in the real world, usually they'll see, thanks for your form submission, something like that. And then you can go back to the page, hopefully a link back to the home page. Okay, so let's pick this thing apart and see all the pieces that we have going on here. So we have action and method. The method is going to be the HTTP method that's used for the request that's created when this form is submitted. Action is going to be the path. So submitting this form is going to create a GET request for the path /form-path. So that's what you should expect on your server. You'll write in what most of you have at this point is a giant if, elif, 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 elif. You're going to write elif, method equals get, and path equals /form-path. Then I know I have a form request. So handle this form request however your code is supposed to handle that, however your server is supposed to handle that. Then we have inputs. Inputs have many, many, many types. I'm only going to show a couple right here. But if I have type text, this is going to be an input that is a text box. And then I'm going to give it a name. This name is important. That name is going to be the name used for that value when it's sent to your server. So when your server gets this data, it's going to get some value labeled as commenter, and you know that that's whatever the user typed in this box. So these names, use some meaningful names so you don't confuse yourself. Probably not the names I used here, comment and commenter, they're too similar. But use some meaningful names that won't confuse you when you're parsing these requests on the other end, because your names that you choose here are going to be used in that request. And you absolutely should, I'll say should, but please do this, add labels for all of your inputs. There's a few reasons for this, and there's a few different ways to set this up too. If you wrap the label around your input, then any text in that label is going to be associated with that input. Two big reasons to do this. One is accessibility, and that should be reason enough. Some people are partially or completely blind and still want to use the internet. And they're using screen readers. They want to know that enter your name is associated with this input, this text box, because they really have no other way. Like, we can visually see that, oh, this probably correlates with this probably correlates with this. If you're using a screen reader, it's not easy to do. That's hard to do. The other reason, the one that even like I can see most of the time, but I can see I still want these labels because that label, since it's associated with the input, if you click anywhere on this text, it'll highlight, it'll put this box into focus. For text boxes, maybe not so much of a big deal, but when it's radio buttons, little circular buttons, or check boxes, I want to be able to click on the text next to the thing and have it select that. It's just one of my pet peeves. It's grown on me over the years. If you have multiple choice, like for the lecture questions, you can click the text next to the radio buttons, and it'll select that button. That's how every radio button should work. Whenever that doesn't happen, you know that that site has an accessibility violation. They might have some legal trouble at some point in time. But it's also annoying for everybody, because just let me click on the thing. Whenever I sign timesheets for TAs, there's this little checkbox, and I have to click exactly on that checkbox instead of the big text that says, I approve this timesheet. I'd like to just click on that text. But it's something I have to live with every 2 weeks when I have 30-ish, 35-ish TAs. I have to do that 35 times, and it pisses me off. Just add your labels. I know how many TAs I have in each class. It's 24 and 15. but I always forget how many TAs are in both. I have some TAs in both classes. That's why I don't know the exact number, if you're wondering. And then an input of type submit. This is going to give you your submit button. Whatever value you give it, that's going to be what's printed on the button. So since I put submit here, I get a button that says submit. And since I did the type as submit, that's what's saying this should be a button. This is the button that submits the form. So once I click this button, that HTTP request is fired off, and whatever the response is, that's what's rendered to the page. And guess what? This is why I did query strings. It might have seemed out of place in this lecture. This is why I did query strings. This is the request you're going to get. Whatever they inputted in that form in a query string. So you're going to send a GET request, since I chose GET as the method, / form path, since that was the action. Start a query string. Name equals the value that I typed into that box. Name equals the value that I typed into that box. And for what it's worth, I do get pluses instead of %20. And then this exclamation point, that's a reserved character. So it got %21. That's the ASCII value in hex for an exclamation point. So this is what we get on our end. A GET request with a query string containing the name and value of our inputs, the value being whatever the user typed in. And this is the request line. Query strings, just a reminder, query strings do go in the path of your request line, which is one big reason why they can't contain spaces. It's going to break your parsers. The fact that a request line has exactly 2 spaces, that's fixed. Nothing's going to change that. No query string or anything else. So space is not allowed in query strings or URLs in general. So there are problems with this. Not huge problems yet, but we're going to run into problems eventually, so we're not actually going to do that. Using query strings, it's fine if you just want to send a little bit of data. It's fine for search engines. I'm not going to type in a ton of data as my search. But there are limits. If you have a lot of information you want to send, there are limits to the entire header portion of your request, which includes your request line. Everything before that first blank line, there is a limit, which is typically in the handful of K range. So not too much. You can't stuff a lot of data in the headers of an HTTP request. You will get limited on these. So we don't want to put too much data. We can't put too much data in our query strings, not even in our headers. Some sites will give you very large cookies, very large tokens in your cookies, and you can start hitting these limits. I hit these, I don't know if anybody else runs into this, but I hit this limit on the hub. I'll go to the hub and it'll say, your request is too large, and then I have to clear my cookies and then go back. It's like, why is it setting such large cookies that it's hitting this limit? It's ridiculous, but we have to live with it. And for example, how would you even upload a file? If you have a file, you want somebody to upload a megabyte file, you can't do this. It's not going to work for you. So post requests. I always said post is how we send data to a server, so why would we even use GET requests? We're going to use post requests. We're going to change our form to use post instead of GET. This is the way we would like to do things. We don't want to send data using a GET request unless that's what's called for. Search engines do actually go to Google or DuckDuckGo. Those were real examples. You go into their search box, it will actually send that data with a query string. So sometimes that's what's called for, which I believe they do that for caching reasons and performance. But when we're sending data to a server, we want to use posts. When we use post, the data is going to go in the body of the request instead of in the URL. Yeah? On the headers only. So anything before that blank line. So in the body, there's no limit. And the reason for this is for the headers, if you have a lot of headers, it's hard to detect that. It's hard to read 20 kilobytes and say, well, I didn't see a blank line, so let's just keep reading stuff. When do you stop reading stuff and say, you know what, this isn't a valid request? You'd have to code something to say to stop. And that code can be attacked with a DOS attack or DDoS because you're going to have some logic that says, when do I stop and throw away this request? Well, if we just cap it at 4K and say, okay, I've read 4K and I didn't see a blank line. This is an invalid request. Let's throw this away. And it limits those types of attacks. For the body, there's no limit because you have content length at that point. Okay, content length is 1 billion. Okay, buckle down. I got 1 billion bytes to read. And then you can time out still for the DDoS attack, but it's more clear what you're supposed to be doing. So if it's a legitimate request with 1 billion bytes, content length is 1 billion bytes, and I got a bunch of data coming, let's do it. And we get this with post request. So we actually get the value, the exact value that the query string would get. We get a URL encoded value. So we do still have to worry about that. And we get our content type of URL encoded, but it's going to be in the body of the request, not in the path. If you look through the homework 2 handout code, this, at this point, is how we're going to do auth. This is how the auth is set up. That said, you are allowed to modify the front end. The door is open if you want to change the way the forms work. But by default, if you're using the handout code, this is how you're going to get your auth requests for register and login. So URL encoding, and that's why I say we won't throw anything that's going to be percent encoded at you. Username and password, we're not going to contain any spaces. So you don't have to worry about those ones, but this is the format. Looking for the ampersand, looking for the equal signs. You will have to look for those. And in that example, I'll foreshadow this with very little detail. This will be big on homework 3. So I'm foreshadowing a whole homework ahead of time. If content length is 1 billion in my example before, and when you go to receive data off the buffer, you have 2K there in the handout, the code that I gave. If you leave that as 2K, which you should, we'll talk about buffering for homework 3, of course. But if that limits 2K, that means read up to 2K bytes, even if there's 1 billion bytes sitting there waiting to be read. You're not going to read all 1 billion bytes. My math, 1 billion is larger than 2K. It's not going to work for you. So if you don't read content length number of bytes, you have to go back to the TCP socket and read more bytes. And we'll do that in a loop and keep reading until you read content length number of bytes. For homework 2, you might get away with just reading the whole thing and handling it that way. But you really should be checking to make sure you've read content length number of bytes. If you don't do it for homework 2, you will have to for homework 3. Homework 3 is going to be image uploads, and we're going to test with megabytes size images. We're going to make sure we're hitting your buffering. All right, AJAX and polling. So this is great, right? We have forms. We can interact, kind of, but whenever somebody submits, it's going to cause a page reload. So for register, for login, we're going to live with that. That's going to be fine for us. But what about sending chat to the app? For homework 2, you're going to be building chat. You're going to type in your message, click send it to chat. We really don't want a page reload every time we send a message. And more importantly, we don't want to force a page reload every time we get a message. Every time a message is sent by someone else, I want to see that message without having the page constantly reload. The page reloads, among a lot of other issues, if the page reloads every time somebody sends a message to the site, and I'm in the middle of typing a message, my message just got wiped out. Like, I don't want to deal with that. So we want to send and receive messages without a page reload. So we need a bit more functionality here. What we need is a way to send HTTP requests after the page loads. So the page loads, everything's fine. I want to send a new HTTP request without reloading the page with the contents of the response. And this is where AJAX comes into play, which is this dumb thing. Asynchronous JavaScript, which makes 100% sense, and XML. We don't use XML anymore, but that has really stuck with it. So it's AJAX and not just AJAX. I guess that doesn't sound as cool anyway. But asynchronous JavaScript and XML. But it's a way to send an HTTP request asynchronously with JavaScript. So it's going to be fired off, and then everything else, all your other JavaScript, is going to keep running on the page. And then when that response comes back, it's going to say, okay, I got this response. Let's run this other code. This is back to our event-based architecture. We have the event of receiving that response, and we're going to have some code running concurrently with our other code when that response comes in. And this is what that looks like. You've probably seen these before, but if you haven't, let's break it down. You would see these in 199, I guess, would be, if Alan was still doing 199 when you took it, that's where you would see it here at least. And some of you have probably seen these outside of class, but I know some of you haven't, so let's do it. We're going to create a new XML, and this drives me nuts, but XML HTTP request object. So we're calling this constructor, creating an object. It's XML, even though it has nothing to do with XML anymore. I wish it was just HTTP request or new AJAX request. There's so many other good names for this, but we're stuck with the past. Sometimes the past just comes along with us. Then request, we're going to call open, which is where we're going to specify the method type and the path for this request. Then we're going to call send, which is going to fire that request off. So this is going to fire off a GET request for /path. And then when we get a response, we're going to use this as an event-based action. When the response comes in, we're going to execute this code inside the code block. We do that by setting onReadyStateChange, which is a variable that stores a function. We're going to give this a function that's going to be called every time the ready state changes. And the ready state that we're actually interested in is 4. 4 means that the response has been received. We're done buffering. We're not waiting for a response. Everything's here. The response is here and ready to be read. So if that ready state changed to 4, and we're going to check the status. If the response code is 200 OK, meaning everything's OK, then we know that we can process the response. And here I'm just printing it to the screen, but this is where you would do whatever you want to do with that response. You would do your thing with the actual response. If we want to change this to a post request, we just change it to a post request. We change this to post. Done. And then when we call send, we'll give it a string, which is the data that we want to send. I think send will take an object. I think it will stringify it for us, if I'm not mistaken. I'll just convert it to a string to make sure. But we're going to send it a string, and now we have a post request with our data in the body of that post request. So putting this together, the stark style change, the colors anyway. I didn't realize it was that drastic. So with that, putting this all together, we have a few options to be able to send an AJAX request. Because remember our forms, if we just have a form and we click submit, that's going to refresh the page. That's what we're trying to avoid here. So we have a few options. I'm going to use here the onSubmit property of the form. This is what happens when the form is submitted. I'm going to call a function that I write in my JavaScript and then hit it with a return false, which is going to not reload the page. If you add something to onSubmit after your stuff is executed, it will still do the default action. You can disable default action without doing return false for what it's worth. But I'm going to do this a different way anyway. And return false will exit and then never get to the point where it calls the default action, or you can disable the default action. Either way, we want to disable page reloading. And then send message with form is going to be called. I'm going to grab my form. I'm going to create a form data object with that element. That's going to give me all the data of that form. Create my AJAX request. The onReady state change would be right here. And then put form data in the send. And that's going to send the request just like we did with the form, except it prevents a page reload. And I can handle the response, whatever the response is, I can handle that however I want to handle it. Now I don't have to respond with HTML. I can respond with whatever I want. Some JSON object with some data, whatever I want. A good job, you submitted this form message that gets displayed on some div by replacing the inner HTML, whatever I want to do with that thing. Or nothing. If we don't want to do anything with it, there's a few parts of the homework where we just don't do anything with the responses. You don't have to do anything. Just send the request and let her rip. Here's the way that I have the chat set up in the Homework 2 handout. And this is, I don't know why, but this is my preferred way of doing it. Maybe I should wrap these things in forms, but this is the way I like to do it, is creating a button, just a regular button, not an input of type submit, but a regular old button with an on click that's going to call my message. Now I don't have to override the default actions of a form. I'm just creating my own form from the ground up. On click is going to call send message. In send message, I'm going to grab the elements with the stuff that I want. So I'm going to grab that element, get its value, stuff it in a JSON object, because communicating over the internet, we usually just use JSON. It's the format that won that battle. So I'm going to use JSON here. Well, I'm going to use JSON here. I'm going to create an object here, and then stringify that as JSON, and send a JSON string over the internet, post it to whatever path I want. Now, guess what? I don't have to worry about URL encoding and percents and all that stuff. I'm going to send a JSON string. It can be any UTF-8, anything. It can be whatever I want in that message. I don't have to worry. It can have emojis in it. I don't have to worry about anything because it's JSON. It's UTF-8 JSON. No URL encoding. So that's one of the big advantages of doing it this way. Plus, you have a lot more control over how you handle things here. You're not confined to an HTML form. And you can control the JSON format. We had to use, I already kind of implied this, but you don't have to restrict yourself to that XML, that URL encoding. You can choose whatever format you want. If you don't want to use JSON, don't. Just send it as a regular old string. Send whatever you want. So you have a lot more flexibility doing it this way if you want to build your custom sites. And we have one other issue. When we're receiving data, how do we get data to our site? Somebody sends a chat message. I want that chat message. What mechanism do we have? Because with our toolbox right now, we don't have much. But we can send an AJAX request that says, hey, give me the latest messages. But how often do we send that message? And more importantly, do we wait for the user to take an action to send that message? Does the user have to click refresh chat every time? Hell no, that's boring. Not boring, but that sucks. That's a sucky user experience. We're going to use polling using the set interval method in JavaScript. Give it a function and a time